Hey, welcome ladies and gents to your MN13 notes. It's about parallel lines with a transversal. It's from section 3.2 in our textbook. And as you see, it's kind of an activity. It says explore parallel lines with a transversal singular. Step 1, it says use a protractor to measure each angle in the diagram below. Write the angle measure next to the angle number in the diagram. So at this point, I'd like you to pause this video and use a protractor and measure angles 1, 2, 3, 4, and so on to the nearest whole degree. Okay, so you pause me, and then you can start me when you have those angle measures taken care of. Well, I hope that your angle measures went well. I'm just letting you know that you should have gotten right around 46 degrees for angle 1, 134 degrees for angle 2, about 134 degrees for angle 3. Angle 4 is 46 degrees, which makes sense, obviously, because we've been talking a little bit about those vertical angles and linear pairs. And then when you come down here, angle 5 and 8 are both 46 degrees. I'm going to have trouble writing that down in there. There we go. And angle 6 is 134 degrees. And angle 7 is 134 degrees. So we've got two angle values, 46 degrees and 134 degrees. And if you do add up the 46 degrees and the 134 degrees, you'll notice that it does add up, of course, to 180 degrees, which is a straight angle. Okay, so if I come down here, it says fill in the table below. Actually, you know what? Let me take a step back. I just want to make sure that you see a couple things. One is notice that we're using this symbol or these symbols to represent parallel lines. So here, this and this, these two are parallel. And the other thing that I want to make note of, and just because when we speak, or I'm speaking in class, I want you to understand what I mean by transversal. A transversal is any line segment, ray, that cuts through a set of parallel lines, or just, well, yeah, we'll leave it like that because that's what it usually is. But anyway, so this is the transversal. Transversal is this line in this situation. It's the line that's cutting across the two parallel lines. The reason I was hesitating before is if you have two lines going that way and they're clearly not parallel, kind of like your note guide MN12 and a transversal cutting through. That's why I was kind of like hesitating with saying parallel lines. But I'm just telling you that typically we talk about lines that are parallel and then a transversal cutting through, because as you probably have noticed, there's all sorts of cool patterns when it comes to the angles. So let's talk about those. So it says fill in the table below the type of special angle pairs. We have vertical angles right here, which we've already learned about in MN12. Linear pairs, same thing. But these we've taught, actually it was not MN12, it was MN10 or 11 that we learned about these. But these fellows right here, these we talked about in that last note guide MN12. So you kind of know where they're at. But what we haven't done is notice, because we haven't talked about parallel lines before, is notice the patterns that happen with the type of angles, like corresponding angles, alternate interior, and so on. So let me just maybe take a step back to the vertical angles. Vertical angles, just by definition, are angles directly across from each other if they're crossing. So if you have a cross, these two angles would be vertical angles, or these two. Now we also know that vertical angles will be congruent to each other. So notice that we have a set angle 1 and 4 are vertical angles, and 6 and 7 are vertical angles. Just for the record, we have more. Obviously, we can say angle 2 and 3. Those are vertical angles. And what else do we have here? We could say angle 5 and 8. So we're not listing all of the angle pair relations. We're just listing a couple to kind of make sure that we understand the different angle pair relations. So vertical angles are congruent. We know that from prior experience. Linear pairs are the ones, and again, I find that this is the one that sometimes people forget. They are supplement, they add up to 180, and to give you an idea, this is a straight angle, which is 180 degrees, and notice we have this ray that's breaking it up into two angles, this angle here and this angle here. Those two angles add up to 180 degrees. They share a wall, and so they are, in fact, a linear pair. So angle 1 and angle 2 is a good example. Just to kind of adjust your vision a little bit, if I change the color all of a sudden and I say, hey, you know what? This is the straight angle I'm looking at now, and I notice that here we have a vertical angle, or a linear pair. We have this angle plus that one, which will add up to 180. So I'm just letting you know another linear pair could be 1 and 3, angle 3. Now there's of course plenty of them. You could say angle 6 and 8, 5 and 6, 5 and 7. You can work all the way around each of the groupings if you want to think of it that way. So anytime you cross, you create vertical angles like we've said before, but we also, when you have two lines or segments, whatnot, cross, you also create a linear pair. So those two would be a linear pair, or these two would be a linear pair, or these two would be a linear pair. And more importantly, the linear pairs add up to 180 degrees. Okay, so now let's get to the corresponding angles and so on. Corresponding angles by definition, and we're going to end up with a lot of information here, but I'm going to just kind of remind you that corresponding angles are angles like number 2 and 6. And I'm going to draw it over here. Angle 2 is right here. Angle 6 is right here. They are in corresponding or same positions. Notice if you focus on just these 4 angles here, corresponding is in the top right-hand side. This, in the series of 4 angles, it's in the top right-hand side. So corresponding angles, an example would be angle 2 and angle 6. Another set of corresponding would be, I don't know, 3, angle 3, and angle 7. And you can pause me at any time and come up with your own. There's, angle 7 and 8. Not 7 and 8, I'm sorry. Angle 1 and 5. You could also say angle 4 and 8. There's actually, there's only 4 of them, so how about I write them down? So angles 1 and angle 5. And what's the other one? Angle 4 and angle 8. Now, one thing is to list them like you did in the last note guide, but the more important thing in this note guide is to not only know the names, but understand the patterns that happen with them, with the angle measures. So if you look at angle 2 and angle 6, notice both of them are 134 degrees. Angle 3 and angle 7, they're both 134 degrees. Angle 1 and angle 5, they're both 46 degrees. So what we can say is that corresponding angles are congruent. They equal. The angle measures equal. Now we're going to do that for each one of these. Alternate interiors, just like we had learned before, and I'm going to switch to a totally different color. How about yellow? Alternate interiors are going to be interior, and so let me just kind of say this. If you have two, now of course I'm using a really light color for the sideboard here. If you have two parallel lines, or a set of parallel lines and a transversal cutting through, alternate interior, I just want to say the parallel lines create whether they're interior or exterior. Interior are all these angles. These are all interior angles. In contrast, these are all exterior angles because they're outside of the parallel lines versus the red one angles which are inside the parallel lines. So with that said, when I think about alternate, I'm alternating across the transversal. That's what that means. So if I have this, and we're talking about alternating interior angles, we have the 4 interior angles. The alternating ones are going to be alternating across the transversal. So like this angle and this angle are alternate interior. So they have a certain relationship. And then this angle and this angle has a certain relationship. So now when you come down over here, it says list the alternate interior angles. You're talking about angles 3 and angle 6 are alternate interiors of each other. Why? Because here's the one, here's the other one. And then angles 4 and 5. Now look at those measures. Notice angles 3 and 6 are both 134 degrees, so those are congruent angles. And then angle 4 and 5 are the same angle measure, which is 46, which leads us to say that alternate interior angles are also congruent. So these are pretty big names. We need to get to know them. I know there's a lot of them, so but after a while, after using them for a bit, you're going to find that it's pretty straightforward. Oops, I just wrote. Now we're talking about alternate exterior angles. So here's the interesting thing. So we drew this thing over here. Let's kind of do the same thing where parallel lines. Now the parallel lines don't always have to be horizontal. Just kind of keep that in mind. But I keep being consistent with whatever my picture looks like. But we have a parallel line with transversal cutting through. Alternate exteriors. First of all, exterior angles are this one, this one, this one, and this one. But if we're talking about alternating across that transversal, that means this and this is a set of alternate interior or exterior angles, excuse me. And let's do another one. This set and this set are alternate exteriors. And if you just look at the picture itself, you can see again that those are going to end up being congruent. So let me just first of all list them. So we have angle 1 and angle 8 are alternate exteriors. And again, look at here we have angle 1, angle 8 up in the picture. And then 2 and 7 are the other set of alternate exterior angles. And again, if you compare the angles that we measured earlier, we will note that alternate exterior angles are congruent. And at this point, you're probably going to go, geez, they're all congruent. But that's not always the case, is it? So right now, so far, every single angle pair relation and also the vertical angles are congruent. So this one, this one, this one, and this one. Now the last one, consecutive interior angles, let me just kind of try to describe what those mean. And I know we had a video already on that, but sometimes it's good to hear it again. Consecutive interiors, we have parallel line, transversal cutting through. Interior angles, of course, we mentioned are these 4 right there. So now, consecutive interior means one right after the other. So this and this are consecutive interiors. I'm actually saying hi to Mr. Austin while I'm doing a video here. He's knocking on my window. And then the next consecutive interior, I'm doing a video right now. Yeah, give me just a minute.
It's kind of annoying, isn't it?
No, it's all good. They love it. Right, sorry you guys. Mr. Austin in the house. So I'm almost done here, folks. So the red angles are consecutive interiors, and the gold ones are also consecutive interiors. Notice they definitely don't look the same. And you know what? Here's what I do if I kind of get confused. I draw this transversal even more at an angle, and notice now, if I say these are consecutive, does this angle look like it's the same as that one? No, they don't. And so if you look at up in our picture, like angle 4 and 6 are consecutive interiors. They are not congruent, but they are in fact supplements. They add up to 180 degrees. So let me switch to a better color here. So angle 4 and 6 are consecutive interiors, and angle 3 and angle 5 are consecutive interiors, and they add to 180 degrees. So what does that mean? They are supplements of each other. Supplementary. Trying to use those vocab words because it's important. Okay, oops. So that is, in the nutshell, how this table works, and it's really, really important to note the patterns. Just again, to take a step back, they're all these different angle pair relationships are congruent, except for this one right here. Ooh, that's not highlighting. That's just writing right over it. Sorry, people. I don't know. Is it this one that highlights? Except for this one right here. This is, of course, a linear pair adds up to 180 degrees, which means they're supplements of each other, and also consecutive interiors. Otherwise, you know what? They are all congruent angles, as long as there's some sort of pattern in them. Okay, so let's kind of look at the bottom here. It says, on the back of this note guide, copy the question in diagram 2 in the book. Here's the thing, though. I'm just going to cut to the chase and actually give you the problem right here for your viewing pleasure, so you don't have to track down that book, okay? So it says, the example 2 says, find the value of x and explain reasoning. And that's an important part of this, okay? So I'm going to make the transversal or the parallel lines this way, just kind of shake it up a bit. And then the transversal I'm going to do like that right there. Although I just did that, and now I'm looking at my diagram. I'm going to totally mess up my picture here. This is 115 degrees right here. This is angle 4 right there. And, oh man, I could have done so much better. This little angle right in there is x plus 5. Whew. Okay, so what we want to do is find the value of x. Now keep in mind this is the transversal right here. Ugh, I'm trying to write fast, so it's not working very well, is it? And this here is one parallel line, and there's the other parallel line. Okay, so the first thing we know is that angle 4 is equal to how many degrees? And I would hope you can say instantly it's 115 degrees. And how do we know that? We know that because those two angles are congruent because they're vertical angles. So that's the reasoning part. So this is important. You need to explain your logic as far as how you're coming up with the answer. So if we know that this right angle 4 is 115 degrees, now we need to look at what relationship that has to this angle right here. And we know if we look at it carefully that they're both interior angles. They're not alternating across the transversal. They're actually on the same side. Let me just kind of say it. So notice how this and this, those two angles are on the same side of the interior angles. So those are called consecutive interior angles. So it's really just important to know those words. So what does that mean if they're consecutive interior? Well, that means that angle 4 plus x plus 5 angle is going to equal how many degrees? Now they're not equal to each other. Look at the angles. They don't even look the same. They equal 180 degrees. And so I just want to let you know we know this because of, and I wish I had more space on the right hand side here, consecutive interior angles. That looks like an H, but it's actually an N. Okay, now so we can say this, that these two angles add up to 180 because they're consecutive interior angles. We know that angle 4 is 115 degrees plus the x plus 5 equals 180 degrees, and then it's a matter of just solving algebraically, right? So we have 120 plus x equals 180, x equals 60. So we know that the unknown is not 60 degrees, but 60. But if we wanted to know what actual angle is in there, of course that's 65 degrees. If you take 115 plus 65, you'll get 180. And I do want to say, yes, you can figure it out kind of mental math-ish, but in this case, you're going to need to write an equation. Just giving you a heads up, because if all of a sudden you bring something up and show it to me, I'm going to be like, where's your equation? You're going to need to show your equation, and you're certainly going to need to verify how you're coming up with that by using the proper verbiage, or words I should say, and coming up with the answer. So those are the three parts that you definitely need to do. And I think that's it, right? Okay, so if you have any questions on this, we'll answer those in class, but otherwise, thanks for tuning in.